Today we're on page 418. We're going to be covering pages 418, 419, and 420, which is Conditional Probability, Unit 12, Lesson 4. I'll probably be using colored pens, so if you happen to have 3 colored pencils or pens, it might be helpful. And calculator just for adding, subtracting, and dividing purposes. The homework is page 421 and 422. So before we start conditional probability on page 418, which the actual title is on the bottom of page 417, lesson 4, conditional probability. Remember, you need to know that one formula already is that the probability of A or B is equal to the probability of A plus the probability of B minus the probability of A and B. So that's a formula you need to know. And when looking at working with a Venn diagram, you know that the overlapping region here, this is the and. And the two circles combined, this is our or. And we know symbols for and or. The symbol for or is the union of. Looks like a U. The symbol for and is the intersection of, which looks like, I think I changed it to saying that it's, well, it looks like an upside down U or a rounded capital A without the horizontal for and. Okay, so now today we're going to learn another formula and another symbol, a new symbol. When probability of one event occurring changes depending on the events occurring, then we say that there is a conditional probability. Conditional probability can be developed with two-way frequency tables. So we're revisiting a two-way frequency table we saw in the last lesson. We had 52 graduating seniors who were surveyed as to their post-graduation plans, and then the results were sorted by gender. So we have the following letters stand for the following events. M is for male, F female, C going to college, and not going to college. And here's our table. So let me just put going to college C, and not going to college, and male, F female. A person was picked at random from, find the probability that the person was a female. So probability of female, female column, the total is 22. Out of how many? 52. Or approximately, we can keep the fraction or you can reduce it, or if I round to 3 decimal places, 0.423. Probability of going to college, 29 out of the 52. Or approximately 0.558. C, going to college given they are female, which is notated by this vertical segment. All right, when you see this, so this C, vertical segment F, this is college given female. So this is the symbol for given, just a vertical segment. So I'll say probability of college given female. So that means we're looking at just the females, right? And we did this in the last lesson, right? So we're looking at just the females. And of the females, given that the person is a female, how many of them are going to college? 13. So that'd be 13 over 22, which is approximately 0.59. Draw a Venn diagram to help justify the ratio that you give as a probability. I don't think that was necessary, but for practice for drawing the Venn diagram for female, remember our lollipop stick would be the total number female, which is 22. Going to college, it's 29. And the intersection of female and college is 13. So the probability of going to college given female would be these 13 out of the 22 female. D, which is more likely? That a person picked at random will be going to college, given they are male. The notation there would be probability of college given male, or that a person will be male given they are going to college. Okay, so I'm going to, let's see, use colored pens here. So given they are male going to college. Okay, so I now have to go back up to the table, and we're looking at our males, which are these, right? These are our males. And how many of our 30 males are going to college? Well, 16 out of 30. Which is approximately, well, it equals 0.53 repeating. We'll switch to red. The probability of male given that they're going to college. So now we're looking at the row going to college, in which case there's a total of 29 going to college. And of those 29, how many are male? 16. Which is approximately 0.55. Which is more likely? These are too close to judge, really. I mean, yes, probability of male given college is slightly more likely, but I would say, well, okay, so I'll say probability of male given college is slightly more likely, but ever so slightly more likely. So I like too close to judge. Exercise number 2. In the generic Venn diagram shown to the right, each dot represents an equally likely outcome of the sample space. Some of these fall only into event A, some only into event B, some in both events, and some in neither. Consider the probability of A occurring given that B has occurred. Give a formula for this probability based on counting the number of elements in each set and their intersection. Okay, so I think I will try to use, I'm going to use this as A. And there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 dots in circle A. And I'll use blue for B, for circle B. And there are 2, 4, 6, 8, 10, 12 dots in circle B. And there are 4 in the intersection. I think they have share 4 here. So the probability of A given B, well, we know that the denominator is the probability of B, and the numerator is, given that we're in circle B, what's the probability that it's A? And that is the intersection. So that's the probability of A and B is the numerator. So it says counting the number of elements. All right, so I'll switch to element numbers. So that means it's the number of elements in the intersection A and B divided by the number of elements in circle B. I want to do this. So the probability of A given B would equal 12. I'm looking at actual probability. Let's see, denominator is 12 and the intersection is 4. So that's 4 12ths, which is equal to 1/3, or 0.3 repeating. And the probability of B given A. Given that A has occurred, so we're only looking at the dots in A, which there are 10, the probability of B happening is 4. 4/10 is 0.4. So this is actually, if I go back here, this is actually our formula. The conditional probability formula, which you have to memorize. I think it's typed out on the next page. Okay, a survey was taken to examine the relationship between hair color and eye color. The table below shows the proportion of people surveyed who fell in each category. If a person was picked at random, find each of the following conditional probabilities. Show the calculation you used. Okay, so find the probability that the person picked had brown eyes given that they had blonde hair. So given they have blonde hair, so you're only looking at the blonde hair, which would be this column here. Given that they have blonde hair, what's the probability they have brown eyes? So brown eyes, blonde hair, that's this here, out of the total blonde hair. So I'm going to say probability brown eyes given blonde hair is equal to, it's the probability of brown eyes and blonde hair divided by the probability of blonde hair. Do you have to write this each time? No, of course not, because we already saw that our answer is going to be the 0.10 divided by the 0.35. Well, hello, sunshine, and now I have a little bit of shadow, but hopefully I can work through this, which is approximately 0.29. Find the probability the person had red hair given that they have green eyes. Oh, so we'll go with green. Green eyes is going to be our denominator, right? That's our denominator. That's another way it might help you. This vertical segment is for given. Right? It's the word given, right? But if you also think of it as division, right? Because our probability would be a fraction, something divided by something else. It's the green eyes. It's red hair divided by green eyes. So the green eyes total goes in your denominator, right? And red hair and green eyes goes in your numerator. So green eyes total, looking at this, green eyes total is 0.25. And in this row, where's our red hair? Right here. So 0.15 divided by 0.25, which is equal to 0.6. Probability A given B means event A given event B has already occurred. And again, there's a symbol. It's called a conditional probability. Probability of A given B is called a conditional probability A given B. In other words, event B already happened. Now what is the chance of event A happening? And our last example here, when a room is randomly selected in a downtown hotel, the probability that the room has a king-size bed is 0.62. So king-size bed is 0.62. The probability that the room has a view of the town square is 0.43. And the probability that has a king-size bed and view of the town square. So king-size bed and view. All right. Do that. Let K be the event that the room has a king-size bed, and let V be the event that the room has a view of the town square. What is the meaning of K given V in this context? Well, it's the probability that a room has a king-size bed given that it already has a view. And of course you can switch those around. Given a room has a view, the probability it has a king-size bed. The probability that a room has a king-size bed given that it already has a view. Use a hypothetical 1000 table to calculate the probability of K given V. Okay, so king-size bed is 0.62. So king-size bed, the total, 0.62 times 1,000 is going to be 620. Let's see. There we go. And then a view of the town is 0.43. So view total 430. And king size bed and view, which is here, is 0.38, so 380. Okay, you can certainly stop the video now or pause the video and fill in the rest of this table, right? So 380 plus 240 would bring me to 620, and then 380 this way plus plus what will give me 430, 50. This is 1,000. So 620 plus 380 is 1,000. 430 plus 570 is 1,000. And 50 plus 330 is 380. And just check. Yep, that does sum to 570. So now if I go back up here, the probability of king size bed given view, so I'm looking at just my view, right? So there's 430 that have a view, and of those, 380 have the king size bed. So 380 over 430. So here's our formula, which we wrote down on the previous page, but again, write it again. The probability of A given B is equal to the probability of A and B. And remember the symbol for and is the like the rounded capital A with no horizontal segment over probability of B. You have to memorize that. Use this formula to calculate the probability of K given B. Okay, so it's the probability of K given B is equal to the probability of K and V over the probability of V. So the probability of K and V is here, is 380. And when we're talking probability, it's always got to be over the total. So really it should be 380 over the total 1,000. And the probability of V, view, is 430 over the total of 1,000. But these 1,000, since it's denominators, and in the numerator and denominator are the same like that, they're just going to divide right out. So instead of having a fraction over a fraction, usually we just leave off the denominators. So this is 380 over 430, which is the same as we got above. How does the probability calculated using the formula compare to the probability we calculated using the hypothetical 1,000 table? They are the same. Okay, so in recap, you need to memorize that the probability of A given B is equal to the probability of A and B over the probability of B. You must know that. And certainly we know that the and, if we're looking at a Venn diagram, the and is the overlapping region. And then also in recap, what I started the video with was, don't forget that the probability of A or B is equal to the probability of A plus the probability of B minus the probability of A and B. Also need to know that formula. All right, let me just see if I have the homework handy here, which is pages 421 and 422. Mm. Yeah, I think you should be fine. Yeah. Okay. Thank you once again for your attention.